Hello everybody and welcome to the 12.4 video, which is over parabolas. The difference is this is parabolas from an analytic geometry perspective, and the issue that I've had in the past with this section is that you already know so much about parabolas. You know the vertex form of parabolas, you know the standard form, is that when we're adding another form, sometimes the past knowledge can get in the way, but it also can help you understand parabolas more. So I'm hoping to explain this in a way that will be useful to you. And the analytic geometry definition of a parabola is the set of all points equidistant from a fixed point, the focus, there's the focus again, and a fixed line, the directrix. So what that means, equidistant means the same distance from, is let me just draw a standard parabola. If I have 2 points on the parabola that I'll put in green, that would be across from each other because we have that axis of symmetry that goes down. If I have a point inside the parabola called the focus, the distance from the focus to this point and the focus to that point would be congruent or the same. Now we also, in the analytic geometry definition, have a line called the directrix, which is directly underneath the parabola if it's drawn this way. And it turns out that the distance from those points to the directrix would also be the same. So these would be congruent distances as well. And no matter what points I drew on the parabola, if I drew one here and here in yellow, the distance from the yellow to the focus and focus to the yellow is the same. Yellow to the directrix, yellow to the directrix is the same. Makes a nice little M there the way that I drew that. So that is how a parabola is formed from a geometric perspective. And so we're really going to be focusing on the focus in this video and the directrix in order to graph. And something else to know before we continue is that the vertex of your parabola happens to be directly between the focus and the directrix. So this distance and this distance would also be the same, and that'll help us in a little bit. Now here is a bunch of definitions that could help some of you. The way I'm going to teach it is much more visual though, because I feel like it's a lot less memorizing and more understanding. The things I'd like to focus on here though is what the general forms of the parabolas are in analytic geometry. And I would like to focus on what P means. P is the distance from the vertex to the focus, and negative P or opposite of P, depending on which direction we're going, is the distance from the vertex to directrix. Because as I said before, if you have a parabola, you have a focus up here and the directrix down here, the distance from the vertex here and the vertex to the directrix is the same. And so knowing this P value will help, because notice in both equations we have a P value. A parabola is a vertically based parabola if the x is squared. Because if you think about in your past, if you have y equals x squared, that is a parabola centered at 0, 0 that is facing upwards. So whenever you see an x squared parabola, it's the normal type you expect. However, if you see a y squared, that means your parabola is either going to be facing this way or is going to be facing this way. This is if the y squared is positive. This is if y squared is negative. Over here, again, based on your previous knowledge, this is when x squared is positive, and this is when x squared is negative. One other thing to point out is that this 4p value in both situations is really going to help determine not only what the p value is, and this will come into play in a bit, but also focus on this focal length. Focus on the focal. Sorry about that. Pun not intended, but now definitely intended. So the focal length is going to be, if I drew a parabola, it's going to help determine the distance from here to here so we know how wide the parabola really is. So we'll come to that when we get to an example. So what I'd like you to do is pause the video here. And we're not going to discuss it now, but I want you to write down what differences you see between these three equations. This, in the past, has been vertex form of a parabola, standard form, and then the one I just talked about. So I'd like you to write things you see that are the same and different, and we'll discuss it in class the next day. So please pause now. So I'd like to dive on into this first problem, and I noticed that the x is squared, which means that if x is squared, it's what we're used to. So my parabola is either going to be facing up or facing down. Now, to determine that, it looks like right now that the x is positive. But again, a lot of things in this section depend on this number in front, because that number has to do with 4p, and most things depend on p. So I'd like to point out that if I divide by a -1, because this is negative, my equation becomes negative x plus 3 squared equals 8 times y plus 5. Notice the parentheses don't change sign, just the numbers on the outside. So it turns out that my x is actually negative, which means it's going to be a parabola facing upside down. So because now I know that the parabola is based on x squared, I'm going to write the general form right above it. X minus h squared equals 4p times y minus k. Now, this 4p, again, represents the focal length, which is the segment that determines how wide the parabola is. So because I have a 4p in my equation, that means that my 4p is going to be 8. So just to draw a sketch, if my parabola is eventually going to be facing upside down here, I know that the distance from one side of the parabola to the other will be 8. And so please keep that in the back of your mind for later. What's really important at the beginning of these problems is to first find p. And why does that matter again? Well, if I go back, remember that p is the distance from the vertex to the focus and from the vertex to the directrix. It's the same here and here. So if this distance was 2, this distance would be 2 as well. And the reason it's p and negative p is it represents an opposite sign or opposite direction that you move. So if I go back to this, I notice that 4p is in the same position as this 8. So I can set 4p equal to 8, get p equals 2, and this represents the distance from the vertex to the focus and the directrix. So if I found my vertex first, that would be at -3, -5. So if I graph that point here, -3, -5 would be here, and then I would have to go 2 units in each direction. Because my parabola is facing down or more vertically based, I would go up 2 and I would go down 2. So one of these points would be my focus and one of these points would be my directrix. Now something I would consider writing down is that your focus is always inside the parabola. Always inside the parabola. So because I know my parabola is going to be facing downwards, I know that this would be my focus. And I know that my distance from side to side is 8 units, which means from the focus I would go 1, 2, 3, 4 this direction, 1, 2, 3, 4 this direction. And so my parabola would look something like this. It has to go through the vertex and these 2 points. So it would be a pretty wide parabola facing downwards. This is my focus and this is my directrix, so I'll draw a horizontal line through that point. Now that I have this visual, I can find the rest of the information much more quickly. The focus now is at -3, -7. The directrix is the line y equals because it hits the y-axis right here, so it will be y equals -3. And the axis of symmetry is the line that cuts the parabola directly in half. So this would be an x equals line, and it also happens to hit the x-axis at -3. These will not always be the same. This is a coincidence for the first example. So again, I want to point out to you that yes, all of these formulas are here to help, but I think that parabolas make a lot more sense if you think about what p really means, what the focal length means, draw a picture, and then answer these questions. I think it will be much, much more helpful for you, not only for the future test, but also your final exam. Now the question is, which I've answered in every video so far, how do I determine what a parabola looks like if it's not given to me in standard form? Well, in order to know that, only one of these terms will be squared. So if I look back at my general form here, if I go back to this, notice in both situations either y squared here, x squared here, but not both. So if you're ever trying to identify it, only one term is squared, which leads me to this example. Notice that only y squared is squared, so I know it has to be a parabola. And what we're going to have to do for this example is complete the square again, because I have a squared term and we need to eventually be able to factor to get it into a parenthesis form or vertex form. So what I'm going to do is leave the y terms on this side. However, if we look back at the general forms, notice that the other variable's on the other side of the equation. So that's exactly what I'm going to do. I'm going to move the 4x over by subtracting it, and I'm going to move the 33 over by adding it. I'm going to take a GCF out of -1. When I do so, I'll be left with y squared plus 2y, negative divided by negative, plus blank equals -4x plus 33 plus blank. Now I can't complete the square on this side because my x term is not squared. So I'd have -1. My b over 2 squared is going to be 1. And then on this side, I'd add a -1 because -1 times 1. So I'd have y plus 1 squared equals -4x plus 32 on this side. So from there, again, I'm just noticing some patterns that if I go, again, back to my general form, notice that this side has parentheses and this side has parentheses. So maybe I can take a GCF out over here as well. So I would have -1 times y plus 1 quantity squared equals -4, and then I take out x minus 8. I see two things that are negative, so I might as well divide both sides by a -1, and I would be left with y plus 1 squared equals +4 x minus 8. So this would be the form of my parabola in an analytic geometry perspective. Notice again, when I divided by a -1, it only changed the numbers on the outside, not inside the parentheses. That is a common theme throughout a lot of these problems. Speaking of common themes, let's take a look at what kind of parabola we think this is. This time, the y is squared, which means that my parabola is either going to be facing this direction or this direction. And what's interesting is that these are definitely not functions because the vertical line test wouldn't pass. In fact, a hyperbola isn't a function, and also an ellipse isn't, or a circle. Interesting. So I noticed that the y is positive and this is positive also. So I'm thinking between these two, it's going to be this one because it is a positive y squared and the y squared, so it's going to be facing to the right. So let's start graphing this, shall we? The vertex of this parabola, and be careful about the order here, x comes first, would be at 8, -1. So if I graphed that point, that would be right over here. Everything depends on the p-value again. So if I write the general form underneath, y minus k squared equals 4p times x minus h, I know, because 4p equals 4, that if I drew a sketch of my parabola, the distance from this side to this side would be 4 units, because 4p is that distance. Again, my goal is to find the p-value because it helps with other things. So if I set 4p equal to 4, I would get that the p-value is 1. And what this represents is the distance from the vertex to the focus and the vertex to the directrix. Because I know that my parabola is facing this direction, this would be my focus and this would be my directrix, because it's eventually going to look like this. So I'm already going to draw a little line through the directrix there. Again, to figure out how wide the parabola is, I know that the distance from side to side is 4. So from the focus, I would go 2 in each direction. And again, I have to go through my vertex. So my parabola would look something like this. Now that I have that picture, I can answer all of my questions more easily. The focus is at 9, -1. The directrix is now a vertical line, x equals +7. And the axis of symmetry this time is going to be a horizontal line because it cuts the parabola directly in half this way, and that looks like y equals -1, a horizontal line. All right, guys, like the last couple videos, I did not have enough time to do the last example, so I will make a short part 2 for the third example. Thank you again for sticking with me.